Master RM501, right? Is a robot. Now I will share the link to you. You can also simulate, right? Please copy the link to your computer. You can also share to some your friends. Then you can also simulate, right? It is the brand of Mitsubishi Move Master RM501. It is a pick and place type robot. We are going to explain what is mean by work envelope and what is mean by degrees of freedom and specification, all these things in this simulation mode, right? It's a simulation environment. Here you can simulate. Here you can see the simulator. Here you can see the simulator. Here you can see the robot. Here 1, 2, 3, 4, 5. See, listen carefully. Here I am having only 5 degrees of freedom. It's a waist portion. It's a waist joint. You can see this. You can see this is a waist portion. This is 1 degrees of freedom. Students, can you able to see the screen now? I'm sharing.
Yes, sir.
Okay, thank you. Now you can see this waist portion. Here you can change. Here it may be 50 or 60 means you can change the angle, right? And change it. You can change it. This is a shoulder. This is a shoulder portion. It is second degree of freedom. This is the elbow. This portion you can change the position. Whenever you are changing this position, this end effector position is also going to change. This is elbow. This is our third degree of freedom. This is your wrist. This is also a degree of freedom. Wrist roll. This is also a degree of freedom. Okay, so in this type of robot, they are having 5 motors, 5 servo motors. 1, 2, 3, 4, 5. No, 5 servo motors, and this 5 servo motors is connected to a controller, and we can program this so that 5 servo motors. Okay, this is called degrees of freedom. In this type, we are having 5 degrees of freedom. Now we are going to see what is mean by work envelope. Here I told you, no, what is mean by work envelope. This is called work envelope. Now this is the formal definition, guys. A robot work envelope is its range of movement. Right? It is a shape created when the robot reaches the forward, backward, up and down. Right? Okay, please wait. I'm going to give you some other terms. It is forward and backward. See, what is forward and backward? We have the terminology in this robotics. It is forward kinematics and next is called as reverse kinematics. Forward kinematics analysis. Next, say for example, this robot is going to move the forward direction. Okay. Now this is in reverse direction. It's in reverse direction. This end effector moves towards the base, then it is called as reverse kinematics. It is a study of its acceleration, its velocity. It's called kinematics. I told you already. Now, this end effector moves towards the base is called reverse kinematics. This end effector moves far away from the base, then it is called as forward kinematics, right? And it can move up and down, right? This end effector can create a shape. We see here you're having a graph, no? It's a graph. Students, can you see this graph here? Can you see the graph? Okay. Here you can see the graph. This graph denotes what? This end effector is creating the path. There is a coordinate. Simply it's creating the coordinate. Okay. So we can clear the plot. Now I am going to create the path. Right. Now it create a path throughout this roll. It can roll throughout this roll. It can create a path for this degrees of freedom. Also this shoulder. So it creates another one path. If you are combining all this, then you can create a volume. It's a 3D. It's a 3D environment. You can create a volume. That's why they gave this 3D graph. The software is developed by this college IIT Kharagpur. Okay. So here you can simulate this. There's a wrist roll you can develop. Okay. You can develop all this workspace. So finally, it will create this space for working. So this is a total workspace. Right. In this volume, this end effector can move. This volume end effector can move. Please wait. I will lift this shoulder. Okay. I will lift the shoulder. Yeah. Okay. So hope you can understand what is mean by degree of freedom. Next is what is mean by forward kinematics and what is mean by reverse kinematics and what is mean by work envelope. This is called work envelope. I will give you some other examples. Right. Here you're having another one example. This is a type of robot. Here I will show you another one. Robots. Please write. I posted the link, no? Yes. Yeah. So you can select some other Puma 560 like this. It is also a type of robot. You can simulate and you can create the work volume for this type of robot also. This is a simulator. You can learn practically by means of simulation. Here we are having 1, 2, 3, 4, 5, 6. No, this is the 5 and 6 type of motions here. Right? It's a Puma. It is a standard robot. It's a standard pick and place type robot. This is called end effector. I told you already. This is called linkages. 1, 2, this link, and this is called joint. You can move in a 6-way. First degrees of freedom, second degree of freedom, third degree of freedom, fourth degree of freedom, fifth degree of freedom, sixth degree of freedom. Okay, this is called transformation matrix. We will discuss in later. So in our third unit. Okay, here we are going to give this 6 degrees of freedom here. Yeah, you can get this 6 degrees of freedom. You can move. Here you can create this workspace. This is your workspace. It can create automatically. Okay, this is the coordinate. See, this coordinate is x-axis, y-axis, and this g-axis. No, it is 0.44, 0.56, 0.29. We have this coordinate of 0.1, and this is, we have this coordinate, the symbol of minus. No, here is a coordinate. You can plot like this. Hope you can understand what is mean by work volume. Okay. Now, here I am going to give you the envelope of the common robot. This is a Cartesian coordinate robot. Now you can see the common envelope, common work envelope for this Cartesian. Right. In this robot, it can move only in 3 directions. 1, 2, 3. No, it is x-axis, y-axis, and g-axis. We can create, see, like this box. So this box is the envelope of envelope for this Cartesian type robots. This box is the work envelope of this Cartesian type robots. Students, can you able to understand what is mean by work envelope? It is a volume created by the students. Can you able to understand the concept of work envelope? It is the volume created by the end effector. Students, are you there? Shall I continue?
Yes, sir. Yes, sir.
Okay. Now we are going to see this cylindrical robot. Cylindrical robot. In the cylindrical robot, we know this end effector can give a cylinder. See, it is a cylinder-like path, right? So it's work envelope. This is called reach. It's maximum distance it can reach for working. It's called reach. Okay. It is also a specification of robot. Okay. And next, we're having this so many types of robots. This is called articulated robot. We can create a spear-like and SCARA robot. You can create, this is our envelope. It is the envelope we can create, or it is a path it can create, right, for working. This is a SCARA robot. we have this second type of SCARA. The next is Cartesian. In this Cartesian robot, you can bring the box, that's all. The next is called as parallel type robot. We will discuss later in detail what is mean by parallel type robot. Okay, so this is called as work envelope, right? This is called work envelope for cylinder, for this Cartesian, for the SCARA, right? This is called work envelope. Okay, I will discuss shortly about the specifications of robot in detail. Again, here we can specify the robot based on its degrees of freedom and based on its payload capacity and based on its precision and accuracy and based on its speed and based on its repeatability. So these are the specifications we are going to use, okay, to check the performances, right? So here we have this 7-axis robot I told you in this session. Okay, now here we are going to compare based on the specifications. Before that, I have a small PDF to share. Please wait. I will share that PDF file. It's available in Google Drive also. Specifications, yes. Can you able to see?
Yes, sir.
Yeah, thank you. Now, this is a brochure. It's a brochure of KUKA industrial heavy load robot of robots, right? Here, it has a very huge payload. So payload is very high of the range of 300, 450, 600 or this range, right? They are using this type of robots. They gave this work envelope. See, it is called work envelope. Here they gave work envelope in their brochure. Here we are studying so our PPT and our syllabus. They gave in the brochure. Okay, if you are buying for your company, then you should know what is meant by work envelope. Okay, say for example, if you are reading this brochure, then you should know what is meant by work envelope. This is the work envelope. Here they gave the dimensions A, B, C. No, here it is A, B, C. For this KR360 and R2830, we have this three variants of the robot of KUKA series. Here we have this work envelope. Say what is mean by work envelope? This end effector, this end can reach this shape in its front view, and this is the top view. Okay. If you are able to do the drawings in CATIA, then you can merge this front view and the top view. Then you can able to create a 3D view. It's a 3D shape. That 3D shape is the complete work envelope for this robot, KUKA series robot. Student, can you able to understand what I am telling? Okay. Okay. Students, are you there? Shall I continue?
Yes, sir.
Yes, sir. Continue, sir.
Okay. Okay. And we have some other specifications in this brochure. You can see it is axis 1, axis 2, axis 3. It is its degree of rotation, plus or minus. It's having this degree of rotation, range, its payload, speed, etc. They are giving the range. Okay, you can see. Now we are going to compare the robots. We have several brands. I told you already: KUKA, ABB, Siemens, Mitsubishi, Boston Dynamics, Elite, Fanuc, Cobot. Okay, it's also Sany, Ignis, Yamaha. Right. So these are some types of robot. Here you can compare. Here you can compare. This is a comparison tool. Okay. Here you can see this Fanuc. Fanuc, no? Here they gave the specification. It is a payload of 10 kg, and they gave the speed of the links and other things, right? So you can compare using this website. Okay, here comparison tool. Please wait. You can see the specification also about this Fanuc type products, right? Simply I am searching about this websites, this available. I will share that link to you, right? I'll share the link to you. No, you can compare. See the link, it is available in the chat box area. You can store and you can search future. Okay. Now we are going to see about 4-axis robot and the types. Some other types is available in KUKA series. This same session. Yes. These are the variants available with the reach. Here you can see the reach, no? Here I told you already the meaning of reach, right? The end effector can reach the distance of 500. It's a payload in kg. Just 500 in terms of mm. They gave it as mm. Then they gave some applications. Cleaning robot we are using for assembly, for cutting, for deburring, drilling, etc. It is the so it is the use we are going to use. Right. The next is series. It is the variant. This total variant is available in this KUKA only. So because this website is in KUKA. Okay. So we can select and we can find the specifications also. Okay. Simply search the tool, use the tool. Okay, to compare, and here you can know the specifications also. Okay, students, can you able to understand? Do you have any doubt?